Hello and welcome to my first-person shooter 3D Unity project series. In this series, I'm hoping to teach you everything you need to know to make a first-person shooter in Unity 3D, as well as just teaching you some things about game design and programming and just Unity in general. So without further ado, let's get into it. So right off the bat, I am in the Unity Hub application. If you don't have this, you're probably going to want to download it. I covered that when I downloaded in my Unity how to download Unity video. But when you're ready to create a new project, you can go up here to this blue box in the top right, select 3D URP, and this is the universal render pipeline. It's going to allow us to change a lot of the settings and to really customize our experience in the game. If we want to make maybe like a low-end product that's very fast, or if we want to make a very high-end product that's going to require beefier computers, we can definitely choose that. If you don't have this option in the gray box, I know it might be a little hard to see considering everything's in dark mode. You would know if you don't have it if you have the little cloud symbol next to it here. All you have to do is click it and it'll download. So once you've downloaded it, you can select it and you can change your project name. I'm going to name mine FPS project. And then you can choose your location as well. I'm storing mine on the D drive. And then I'm going to click Create Project. And that's going to start setting up the project for us and doing everything that we need to get done. So I will see you when that gets finished. Here we are, finally in the project. So first things first, I'm going to start setting up a scene so that we can actually start working on a prototype area for our character to move around in. If I didn't mention it already, in this project we're going to try to cover movement. So let's see what we can do here. Over here on the left we have our hierarchy, and we can start by right-clicking in this empty space, going down to 3D objects, and we can create a plane. All that a plane is it's just a large square that already has a mesh collider on it, as well as some other components like the transform component. Right off the bat, I can notice an issue, and that is that the position is not at 0, 0, which is in the middle of the scene. So let's go ahead and fix that. You can just select these values and select 0, and it'll correct itself. And on top of that, we're going to need something for our player to represent our player. So let's do that as well. I'm going to create a empty game object, raise it up just a little bit. I'm also going to correct the positioning, except for the Y value. I'm going to put that at 1. There we go. It should look something like this. I'm also going to select this little square in the corner here, make it red, and I'm going to change the name here from game object to player, and I should name it player. I know this is invisible and you can't really see very well, but we'll worry about that maybe when we have a model and in future recording. So I'm going to click add component, and I can type box collider here, and we can add a box collider. What that's going to do is that is going to allow us to collide with this mesh collider, same way as you would collide with something in real life if you were to touch it or hit it or anything else. The colliders really make up the world of game development. Now that we have our collider, let's also add a rigid body right there. And what a rigid body is it's going to handle all the physics calculations. As you can see, it has a mass, drag, angular drag. You can choose if you wanted to use gravity or not. You can add some constraints as well for the position and rotation, if you're maybe worried about the player falling over. And you can also change some other things like collision detection, interpolation, and other. Perfect. This all looks pretty good. So with that done, we're going to do one more thing in the scene here. I'm going to drag the main camera into the player, and that's going to make it a child just like that. We'll do this because it's going to allow us to make the camera move wherever the player is. So let me also move the camera over here to the player. And then let me see where our box is. Okay, I want to move it just above the box, I think. I think actually 1.1 will do. So I just went in here and changed it to 1.1. I'm also going to change this to 0. So I want to also specify that these positions are no longer necessarily world positions, but it's now referencing the player positions. So try to keep that in mind as well. So, perfect. Looks pretty good, I think. Gonna do pretty good for our player. At least for what we need. The next thing we're probably going to want to do is we're going to right click down here in the bottom in our assets. This is all of our files that's going to kind of handle our organization. We have the assets, which is the root and scenes folder, settings, tutorial info. The only one we're ever going to really worry about for now is the folders that we create and the scenes folder. So in the assets, in the root here, I'm going to right click, go to create folder. I'm going to call it scripts, just like that. We're now going to open up that folder, right click in it again, go to create, and click C# script. And I'm going to name this first person movement. All right, perfect. It's going to reload and do a little bit of compiling. We're going to double click on it, and it's going to try to open up Visual Studio. There we go. All right, and right off the bat, this is what we have. So this is, whenever you make a script, this is the first thing you're going to see every time. We have our libraries at the top. We've got our class inheriting from model behavior. We've got some pre-made comments. We have some pre-made functions as well. And these are Unity functions made by Unity. They're very handy. Start is called as it says in the first frame update. An update's called once per frame as the game is running. So if you want something to update, maybe like a timer to count up or count down, you would call that an update function because it's always being called consistently as the game is running. Sweet. So now that that's done, let's actually get to coding. So first thing I'm going to do is I'm going to declare a new variable. So public float, we're going to call it, let's do movement speed, and I'm going to set that to 5.0f. Public is our protection, float is our data type, movement speed is the name, and this is the value we're setting as a default. The if at the end helps Unity know that it is a float. That's pretty important. Next thing we're going to add is another public variable, public float mounts sense. Actually, let's do sensitivity. Let's type it all the way up so there's no confusion. There we go, there's our mouse sensitivity. And then public float up down range. And we'll set that to 6.0. One more variable, and this one's going to be a private one. We're going to set that equal to 0. And then a final variable, and this is going to be a little different. It's going to be a private variable, and it's going to be of type rigid body. Or we'll call it Rigi. So the same way that float is a data type, rigid body is also a data type in this case, and we can use it in the same way. So we're also going to need to make a new function here. This one's also made by Unity. Private void awake. It's going to autocomplete that for us. I'm going to get rid of private just because I like the consistency of it being void. That's just me. You can leave private there, but for me, I like it. So we're also going to do the awake function. I should specify. Let's go and add a comment for this again for consistency. Awake is called before start, right as the game initializes. Perfect. So first thing we're going to do is we're going to want to grab a reference to the rigid body game component. We're going to do rigi get component. I'm going to autocomplete that of type rigid body. And that is going to get the rigid body component off of whatever the script is on. So if the script is on anything that has a rigid body, that's going to get it, and Rigi is now set to the rigid body. So we can now actually manipulate variables referencing that. So if we wanted to change maybe the mass, so we do rigid body dot mass equals 10, we can do that from script instead of doing it in the inspector. That right there is manipulating this mass variable in the component. So we grab the reference to this rigid body with this mass, and we can also do the same thing with drag, angular drag, gravity, all the same thing. It's very handy that way. But we don't really need to be doing this right now, so we'll just get rid of it. In void start, we're going to want to go ahead and lock the cursor to the screen. As you may know, in most FPSs, you can't see your cursor when you're moving around. Of course, if you go to open a menu or use any of the UI, certainly you can see your mouse, but when you're moving around and trying to direct your character, we're going to want to set the cursor lock state to cursor locked mode locked, and that's going to hide the cursor in the scene, so that way we just can't see it. Otherwise, it may feel a little weird. So let's get to the nitty gritty, some of the physics-based calculations and whatnot. I'm a little old-fashioned. I don't like using the new input system, so I'm going to use the old input system. If you don't know what the input system is, I think I will save that for another time. But here we go. Float. I'm going to do dirx, actually. Dot get axis horizontal. And make sure you get horizontal spelled exactly right. This isn't a variable, this is referencing the input system, and it must be spelled exactly the same as I have it. Do movement speed times time dot delta time. And time dot delta time is the time between frames. And we use this because not every computer is created equally. And so we want to make sure that no matter what kind of computer you have, it's going to run at time.delta time instead of at the fastest computer. We're going to make another one for move. Oh, there's Z. Do input dot get axis. This is probably going to look pretty familiar. We'll call it vertical. Multiply it by movement speed again. I'll do time dot delta time again. Pretty easy. And this is going to get the input from our keys. Unity is really handy with the input system that I don't actually have to specify what keys I'm pressing. It already knows to use the arrow keys or WASD. So that's really handy. Alright, now we're actually going to move the player. So we'll do transform.translate, new vector 3, move x, 0, move Z. And then we're going to do... I don't know why I'll keep wanting to do move. It's dir. In my own example, I have move, but I really like direction. I don't know. I don't know why I did this to myself, but I did. Okay, now that we've done that, let's get the... Hold on, let's actually come with this. Why can't I type? There we go. Move the player. And now we also need to do something similar to this where we get the mouse movement. So I'm just going to yoink all this. We're going to call it right X, right Y, right Y. We're going to do mouse X, mouse Y. And we don't need time for this. And we're going to change this to mouse sensitivity. There we go, perfect. There we go. And so this is going to get mouse input for camera rotation. So this is how we are getting, like, whatever our mouse is doing on screen, this is going to record that and save it to the rotation X and rotation Y. And it's going to allow us to remember those variables so that we can use them later. So let's do another comment. Let's rotate the camera now. So do vertical rotation minus equals rotation Y. Do vertical rotation equals mathf dot clamp vertical rotation comma minus downrange, up downrange again, And that's the end of that line. And real quick, I'm going to explain this line. So what we are doing is we are setting the vertical rotation minus equals the rotation y. And we are also saying, hey, vertical rotation, you're going to be equal to a clamped variable between two numbers. So what mathf.clamp does is it clamps the vertical rotation. So it takes in three variables. It takes in the first position, which is what you want to clamp. I say position, the first variable, or the first value, that's the word. The first value that you want to clamp is going to take the minimum and then the maximum. If you can't remember this, you can always right click and go to definition, and it'll take us directly to it. So as you can see, we've got the value, the minimum, and the maximum. Pretty easy. So yeah, this is going to keep us from like breaking our neck when we rotate. So like, if you can imagine, if I dragged my mouse up the screen, we're going to look up. But if we don't have the value clamped, we're going to be able to like rotate our head like 360 degrees and look inside of ourselves and behind us without like turning, like when in an FPS game, if you want to look behind you, you would turn like left or right by dragging your mouse across your desk. But if we didn't have this, we'd be able to look behind us just by dragging up or down, and that would like rotate us. It would just be bad. So clamping the vertical rotation is probably really important. So let's also do camera.main.transform.local rotation. Yep. Equals quaternion.euler. Vertical rotation 0, 0. And semicolon. Perfect. Now that we've got the rotation done, let's also add jumping, because most FPS games you can in fact jump. I'll clean this up a little bit. Beautiful. So we'll do if input dot get key down, key code dot space. Ooh, and that will stay inside the if statement. And mathf dot absolute value, rb dot velocity dot y is less than 0.01f. What have I done? I've done something wrong. Wait, render buffer. What are you? I need to be Rigi, not RB. We'll do RB dot. No, it's Rigi. Why do I do this to myself? Add force, vector 3 dot up times the jump force. Force mode dot impulse. Oh boy, that's a lot of fun stuff. Oh, I forgot to declare jump force. Okay. That was one of the variables I was going to come back to. So we're going to make a new public float and call it jump force. And I think we're going to set this equal to 5 by default. I think that's pretty safe. We'll talk more about these variables in a second, so don't worry about it. But is that everything we need? Oh, I need to explain this. Okay. So what we're saying here is if the input that we give, like if we press the key space, that's what this entire segment means right here. If we press spacebar, right, and we can change space to like A, we can change it to backspace if we want, and we can jump with backspace or whatever. Obviously we're going to use, oh, I think we do scroll wheel, right? Oh, scroll lock. No, not that one. I'll have to look into scroll wheel because I know some pro gamers try to use scroll wheel to jump. Yeah, there we go, space. And the absolute value of the rigid body velocity y is less than this. Jumping, if we press space and we are like not in the air, then we can do this. So as long as we press space and we're not in the air or being propelled upwards, then we can jump. Which is pretty handy because that's going to keep us from, if we didn't have this second part of the check, if we didn't have this, we'd be able to just jump infinitively and we'll just go into space, which is not what we want. Then in the if statement, we're going to add force at a vector 3 up times the jump force, which we specified here. Force mode impulse. So force mode impulse what it's going to do is it's going to add force. My brain, I'm forgetting. It's a way to add sudden force to a rigid body object that gives it immediate acceleration, which is very nice. It's just instantaneous force scaled by the mass of the rigid body object, which is exactly what we want for jumping. So that's what we're going to use. I don't know if you could tell, but those little yellow bars have been disappearing every now and then, and that's because I've been doing Control S, which is saving the file. If you don't want to use hotkeys and you're old-fashioned, you can always come down here and click Save Assets. And just click the Save button. If your scripts aren't working, it's probably because you forgot to save. So be sure you save when you finish writing. And I think that's going to settle it for all of our scripting. Alright, perfect. So let's go back into our scene, and let's take this script here, and let's just drag it down here. And we can see all those public variables we made are just right here, as well as the default values that we set. If we want, we can just adjust these as needed. But I think we're good to go to start testing. I think that's everything. I'm going to do Control S or save again, so that way we know everything's good to go. And we're going to press this play button at the top. Alright. Ooh, it is hard to tell if we are doing anything. Hold on, let me get us like a frame of reference. Cube 0, 0, 0. Everything looks the same. I can't tell what's happening. I'm just gonna add a few more cubes to the scene so we know if something's going on or not. Well, we're definitely here, but we're not rotating left and right. Let's figure out why. Ah, here we go. Okay, I found it. So I forgot to add this line here to actually rotate us horizontally. We need to do transform.rotate 0, comma, rotation x, comma 0, and then we add a semicolon at the end. I completely forgot to use this variable. We wrote it out, everything was good, and we just completely forgot to use it. So yeah, down on line 41, just throw this in here, and I'm gonna add a comment. Rotates player horizontally. Alright, beautiful. Alright, now that that's it's cleared up, we should be good to go now. Beautiful. We can move around, we can jump, and we can't jump into the stratosphere. Oh my gosh! Careful with your jumping. If you're falling over, you can always go into here, go to constraints, and we can freeze our rotations. I believe that was the Z rotation. I don't remember which one it's supposed to be. I always just kind of fiddle around with it until I get it right. Nope, wasn't Z. Oh, it was Y. Got it. No, I lied again. Okay, it's X. So yeah, freeze your X constraint, and it should fix itself. If it's still screwing up, safe bet, freeze all of them. There we go. No longer tilting off. And we're only rotating when we want to. We're moving at the appropriate speeds. Let's go to player, and we can also like change all the stuff. So if I want to like really get to jumping, we can just set that jump force to max. And then just shoot up into the sky. In the right here, we can kind of see, oh boy. We can see right here that our position on the y-axis is really high up. So I'm going to set that back down to like 0. Oh, it didn't like that. Alright, hold on, let me restart it. We can also change our movement speed up to like 10. And we're moving around a little bit faster, probably too fast. 5 does seem to be the magic number. Oh yeah, that just feels comfortable. Very good. Okay. One thing I also want to point out is if you notice down here, I set it to 5, but we're in play mode. If I unclick play mode, it goes back to 10. So the reason for that is that no changes you make will be saved in play mode. So you need to make sure that you are not in play mode when you're making changes. A really good example of that would be if I went over here and I deleted like all this, right? It's, no longer there. And I unclick play, it all comes back. So no changes get saved in play mode. Keep that in mind. It's mostly, any changes you make is mostly used for testing. So we've pretty much done everything we came here to do. I think there's one last thing we want to do, and that is to make a crosshair so we can actually see where we're looking in the center of our screen. So I'm going to right click over here in the hierarchy. I'm going to go to UI. I'm going to add a image, and that's going to automatically create a canvas. And I'm going to change this canvas name to HUD. And I just did that by clicking here, clicking rename. Image, we can rename this to crosshair. And I'm going to go over here to the source image on the right. I'm going to change it to knob, which is just a Unity default that they have. Very nice. If we go to the game view, we can see that it's there, but it's not exactly in the right space. So let's see. There we go. If you click Shift and Alt and click... Oh, I need to walk you through this. Okay. So up here in the upper left, when you've selected the crosshair, select this little target, click Shift and Alt, click in the middle, and it should snap to the center. Perfect. Now we just need to do a little bit of scale changing. I think 0.1 is pretty good for a crosshair. Oh yeah, that looks so good. If you want to make it more noticeable, you can maybe make it like green or yellow, if that helps. Maybe? I think green looks good. We'll make it green, and we'll go into play mode. Perfect. Now we can see exactly where we're looking. We can jump, and we can just kind of make a little obstacle course if we wanted to. Already, we basically have a game, but I think that's everything that needs to be covered in this tutorial. If you have any questions, of course, you can leave any comments in the comment section. And if you think I didn't explain something properly, or I may have messed up in my explanation, then definitely let me know. I am definitely open to criticism, and I am still learning, despite having done Unity for a very long time. So if you think I could have done something better, if you think there was a better approach to something, then yeah, just say so, and we'll look at a change, and we'll look at making it even better. The purpose of the series is to improve and to pull community knowledge so that way everybody knows just exactly what the greatest way to make a first-person shooter is. So, yeah. Thanks for tuning in, and be sure to check out, a friend of mine is doing a 2D shooter game alongside me. And his YouTube channel is called Omnicat Labs. I'll have a link to it in the iCards in the upper right, as well as a end of the video reference that you can use. So without further ado, I think that's everything you need. I hope you guys enjoyed, and please let me know if I messed anything up here. Yeah, bye-bye.